Hey, Math 20-1. Today we're going to look at the quadratic formula and how we're going to use this to solve quadratic equations. And maybe we'll figure out how to find out what the quadratic formula is. All right. So if we're given the quadratic equation ax squared plus bx plus c equals 0, we've solved a number of quadratic equations by completing the square. Let's solve this general equation by completing the square for x and see what happens. So let's do the same steps. Right now I've got ax squared. I'd like to get rid of that a, so I'm going to divide everything in this equation by a. So ax squared divided by a is just x squared, bx divided by a is b over ax, and c divided by a is c over a. 0 divided by a is still 0. Step 2 in completing the square is we want to move the constant term to the side of the equation. Right, so I'm going to minus c over a from both sides. Now I want to complete the square on the left side of this equation. So I'm going to take half the middle term. Half of b over a is b over 2a. And I'm going to square that. So b squared over 4a squared. And I'm going to add that to both sides of this equation. Now I'm set to complete the square. So I'm going to factor the left side. I'm going to simplify the right side. So I set up the left side to be a perfect square trinomial, just like we've been doing. So square root of x squared is x, square root of b squared over 4a squared is b over 2a. Make that a perfect square binomial squared. And the right side of this equation, I want to get a common denominator of 4a squared here. So if I do that, I have to multiply this denominator by 4a, so I multiply the numerator by 4a. So if I just rearrange it a bit, I get b squared over 4a squared. That's this blue term. Subtract. Multiply the numerator by 4a and I get 4ac. Multiply my denominator by 4a and I get 4a squared. I now have a common denominator here, so I can combine those two terms. I can subtract these fractions to simplify. I'm going to take the square root of both sides of this equation now, isolate the variable x, and get rid of that exponent 2. At the same time, I'm going to combine these two fractions. Right? So it looks like this. Take the square root of this binomial squared, I get the binomial. Take the square root of the right side of this equation. Don't forget your plus and minus, and I've got a common denominator, so it's just b squared minus 4ac all over 4a squared. I now want to isolate x, so let's get rid of this b over 2a from the left side of the equation, move it to the right side. At the same time, notice I take the square root of my denominator. There is no square root of b squared minus 4ac. We can't find one. But there is a square root of 4a squared, which is 2a. So I subtracted the b over 2a, and at the same time I took the square root of 4a squared, my denominator of this radical. Kept the numerator underneath the square root sign, and I kept my plus and minus sign. Now I want to simplify this equation. I've got common denominators in my fractions. I can add or subtract those together, so it looks like this. Negative b plus or minus the square root of b squared minus 4ac all over my common denominator of 2a. That's what x equals. So in the general form, I now have a solution for x. I've completed the square for every single quadratic equation now. So I may never have to do it again for any other quadratic equation. I've done it for every one. So I can use this solution for x we call the quadratic formula. So now I can solve every quadratic equation using this quadratic formula. It's not always the most efficient, but sometimes we've got no choice. And it might be easier in completing the square because we've done it already. We've completed the square of the general form to get this solution and this formula. So let's practice using this then. So here I have to solve 2x squared minus 5x plus 2 equals 0. We're going to use the quadratic formula. So we have to know the values for a, b, and c. So a is the coefficient of x squared, b is the coefficient of x, and c is the constant term. So once I know those, I can plug them into my quadratic formula. So negative b, negative of negative 5, plus minus b squared, which is negative 5 squared. Must have the brackets around the minus 5. Minus 4 times a, 2, c, 2, all over 2a, a is 2. Let's simplify this. Minus negative 5 is just 5. Negative 5 squared is 25. Minus 4 times 2 is minus 16. all over 4. 25 minus 16 is 9. I'm going to take the square root of 9. That is 3. So I've got x equals 5 plus or minus 3 all over 4. And now I've got two solutions. 5 plus 3 over 4, which is 8 over 4. Or 5 minus 3 over 4, which is 2 over 4. And simplify these. 8 over 4 is 2. 2 over 4 is a half. So those are our solutions to this quadratic equation using the quadratic formula. Try another one. Again, I think it's important to identify your variables. A is 1, B is minus 6, C is 7. All right, plug those into our formula. A is minus 6, so minus negative 6 plus or minus negative 6 squared. Minus 4 times A, we said A was 1, times C, we said C is 7, all over 2 times 1. So again, let's simplify that. Negative 6 squared is 36. Minus 4 times 7, which is 28. 36 minus 28 is 8. So you got negative negative 6, so 6 plus or minus root 8 all over 2. Now, root 8 we should be able to simplify. That was from grade 10. We know the square root of 8 is the same as root 4 times root 2. 4 is a perfect square root, 2 does not. So I can simplify radical 8 as 2 radical 2. So we should do that in our solution. X equals 6 plus or minus 2 radical 2 all over 2. And now we should be able to simplify. Every term in the numerator can be divided by 2. So 6 divided by 2 is 3. 2 root 2 divided by 2 is just 1 root 2. All right, so we only divide the coefficient by 2, not the radicand. So this is the solution to our quadratic equation. X equals 3 plus or minus root 2. So that's two solutions again, right? 3 plus root 2 and 3 minus root 2. Excellent. Let's solve a quadratic equation that has no real roots. How does that look? Well, let's try one here. I'd like you guys to pause this recording and go ahead and solve this equation using the quadratic formula and see what happens. See how far you can get. Away you go. All right, so here's what we should have if we substitute into our formula. Minus negative 5, that's the b value, plus or minus negative 5 squared minus 4 times a, which is 1. C is 7, all over 2 times 1. So we simplify that. Minus negative 5 is 5. Negative 5 squared is 25, minus 28. So 25 minus 28 is a negative 3. So we should have 5 plus or minus root negative 3 all over 2. Well, we can't take the square root of a negative number. We know that. So that's why we say there are no real roots for this quadratic equation. There are imaginary roots, but no real roots. So I could look at the square root of negative 3. A little bit of an extension. I could say that the square root of negative 3 is not defined by the real numbers, so it has no real roots. All right. Let's look at solving quad equations with no real roots using complex numbers. So let's say we've got this equation, x squared plus 1 equals 0, or x squared equals negative 1. This has no solution in a set of real numbers. There's no value of x that if I square it will ever equal negative 1. Not in the real number system. But if I extend the number system, we can give meaning to the solution of this equation. We're going to do this by defining I with the following property. We're going to say that I squared equals negative 1. Right? There's no real number that does that, so we're going to call this an imaginary number. Some imaginary number squared equals negative 1. Or if I take the square root of both sides now, I would equal the square root of negative 1. We know there's no square root of negative 1, so that's an imaginary number. So since there's no real number that has its square as a negative, the number I is not real. It cannot be expressed as a decimal. It cannot be expressed as a point on the number line. For these reasons, the square roots of negatives are called imaginary numbers. So we're going to use this imaginary number to help us simplify some solutions to quadratic equations. So let's go ahead and solve this quadratic equation using the quadratic formula. So again, b is negative 6. We substitute that in. A is 1 and C is 13. So we get 6 plus or minus 36. The square root of 36 subtract 4 times 13 which is 52. So negative 16 results. 36 minus 52 is a negative 16 inside the radical. Again, we said we can't take the square root of a negative number. So now we have to go to our imaginary number system. All right. So we know that the square root of negative 16 can be written as the square root of 16 times the square root of negative 1. Just so we did radical 8 was radical 4 times radical 2. Well, the square root of negative 16 can be written like this. The square root of 16 is a perfect value of 4. And we know the square root of negative 1, we just learned that, is I. So I could rewrite the square root of negative 16 as 4i. 4 times some imaginary number. So I can simplify radical negative 16 as 4i. So my solution to the equation now looks like 6 plus or minus 4i all divided by 2. And every term up here is divisible by 2. So I simplify that and I get x equals 3 plus or minus 2i. Again, there are no real roots to this equation, but we do have some imaginary roots and we've simplified it as far as we can. All right. So the roots of this equation are 3 plus 2i and 3 minus 2i. Okay, here are a few questions for you to try in class tomorrow. Remember, if you have any questions on the notes, we'll go over them at the start of class.